Morning, guys. How are you doing today? I am here to teach you some more algebra. How exciting is that, huh? All right. Windy day today. Today is actually Monday, so today is a windy day. So hopefully you guys are okay and your powers are good and just what we need, right? Power outages when we're online learning. Anyhow, we are going to continue with operations with radical expressions. So it's kind of like what we just did in 6-4, but we're just adding a little bit to it, kind of bulking it up a bit and adding some extra things. We're going to put some pieces together. It might seem like a lot, but in reality, it's just extensions of what you already know. Now I'm going to start with this idea of the product property. We've been using it, but we haven't actually worded it. Basically, what it just means is this. If you've got a radical and you got two things under the radical, you can multiply them both separately. And it doesn't matter what this root is, as long as they're consistent, they're fine. And conversely, it works the same way, that if I had a square root of x times a square root of y, it's the same as the square root of xy. Basically, whatever's under the radical stays under the radical. So let's say you had something like this. You had a square root of x times b square root of y. Well, the a's and the b's are not under the radical, so they stay not under the radical, and x and y are under the radical, so they stay there. Now, of course, they can come out of the radical depending on what the number is or expression is, depending on how many there are. But that's basically the product property. We've been using it. So just a refresher. Product property can be used to break about this. We can break these all up, but let's break up 45. 9 times 5. I'm going to stop right there. You know why? Because what do you know about 9? It is a square number. So we're going to do all these separately. I could write them out separately, like square root of 9 times square root of 5 times square root of 3, x cubed, but it takes extra time and it wastes some paper and we don't need to. All right, what's the square root of 9? Well, that's 3. That's taken care of. What about the square root of 5? Well, you can't reduce it, so that's going to stay under the radical. It's going to stay. X cubed. Well, what's x cubed? The square root of x cubed? Well, we do 3 divided by 2, and 2 goes into 3 one time, and it leaves us 1 under the radical. So maybe we should do this. The 5 stayed, and x stays. All right. What about y to the 8th? Well, remember, it's a 2 out there. 8 divided by 2 is 4. And there's nothing left underneath. So the answer would just be 3x y to the 4th times the square root of 5x. Now, this is stuff we've done last section, and you guys did pretty well on that, so I'm not too worried about that. But again, we're going to ramp it up a little bit. But another example might be the cube root of 125t6w squared. So can we do each piece? 125. Do you recognize 125? You know what that breaks down into? It's 5 times 25, which is 5 times 5. 125 is 5 cubed. So it is 5 cubed. So we do our old properties that we've been doing with the product property. We multiply them all together. What's the cube root of 5 cubed? Well, 3 divided by 3 is 1. A 5 comes out. What is t to the 6? So 6 divided by 3. 2 come out. Nothing left inside. The w squared, oh, it's a cube. There's not enough w's to come out, so that w stays under the radical. And that's that answer right there. And of course, this was the answer over here. So that should be kind of a recap of things we've already done. Okay. Couple more examples, I guess. Let's just take care of this. All right, 48, we're in the 4th root. So 48 would be the thing we got to worry about. Let's see, what is that? Is that 6 times 8? Is that what 48 is? And that's 2 and 3. That's 2 and 4, and the 4 is 2 and 2. So if you notice, we've got 1, 2, 3, 4. 2. So this is 2 to the 4th times 3. All right, let's rewrite this. fourth root, we have 2 to the 4 times 3 times v to the 8th times z to the 13th. Now I already know there's going to be something staying under the radical, like that 3 is not going to escape. So we're going to have something come out and something stay in. Now 2 to the 4th, the fourth root of it, so 4 divided by 4 is 1, so a 2 comes out. 3's got to stay, so let's put it over here. 3's underneath, not going anywhere. All right, v to the 8th, 8 divided by 4 is 2. It goes in evenly, so no v under the radical. Z to the 13th, 13 divided by 4. 4 goes into 13 3 times. But 4 times 3 is 12, so that leaves 1 left over. So just to make it a little nicer looking, although the answer looks pretty good the way it is, cube root, fourth root, I'm sorry, of 3z. The only thing I'll say, be careful when you write these things out. You don't have to worry too much about me not really writing them to me, but be careful these don't get mixed up together. Sometimes when you write them fast, you don't know if it's a cube root or a fourth root or a cube power. Just be careful when you write them. All right. And this one. Now, if you recognize 8, this will be pretty simple. 8 is 2 times 2 times 2. So the cube root of 8, whoops, I don't want to do that. I know, we'll do it that way. So 8 is really 2 cubed. And then we have g cubed. And then we have k to the 8th. Let's do each part. The cube root of 2 cubed is 2. The cube root of g cubed, 3 divided by 3 is 1. It's just a g. The cube root of k to the 8th. All right, how many 3's can we take out? So 3 goes into 8 twice, with 2 left over. So that k squared stays because there's 2 left over, and there's your answer. All right. How's that for a recap? Is that okay? All right, now we're going to take it and apply it to quotients. Now, quotient means divide. So in the same way, if I do this, that really means I'm taking the square root of each one separately, and vice versa. So if I started with this, it would go back to that. That's the quotient rule. How does it apply? Well, this just means the square root of 11 divided by the square root of 9. Square root of 11 is nothing we can do about. Square root of 9 is 3. There's your answer. Now remember, one of the things about simplification is we cannot have a radical that stays in the denominator. So if this didn't come out to be a whole number, we'd have to do something else, and that's called rationalizing. I think you remember that. We're going to take care of that later, and in this section a little bit later on. All right, 1/16 c to the 4th d to the 7th. So it's a square root. Now, if you recognize the square root, in fact, let me write it like this. On the top, whoops, there's not a 6, I don't know where that 6 came from. On the top is c to the 4th d to the 7th. On the bottom is the square root of 16, because remember, that's 1 over 16, so that's like in the denominator. So let's do it. It's a square root. 4 divided by 2 goes twice, nothing left over. 7 divided by 2 goes in 3 times, so 3 comes out, a dq comes out, but a d has to stay. All right, because there's 1 left over, and the square root of 16 is 4. So there is your answer. There's nothing else we can do to simplify that. That is done. All right. What do you think of the divide? It's pretty much the same thing. You know, some more examples. I'm going to break them up. The square root of 9a to the 5th over the square root of 64 b to the 4th. Should write my square root. Don't forget it. That's a common mistake that's made. And you see, I make it, so don't forget. Don't do that. So do each part separately. Square root of 9 is 3. The square root of a to the 5th. Well, it's a 2 out here, right? So the square root. So 2 goes into 5 twice, with 1 remainder. All right, square root of 64 is 8. b to the 4th squared. 4 divided by 2 is 2. There is our answer. Nothing else you can do to simplify it. Remember, simplifying means we can take out as much as we can take out, and in the denominator there's no radicals. We haven't reached that situation yet, but we All right, so you're okay here. All right, up here, the cube root of 162 over 8a cubed. Now, just so you're wondering, I'm not playing tricks on you. It did say fourth root a moment ago. I changed it to cube root because that's what I meant to write. Okay, so we're going to break it up. The cube root of 162. Well, 162 might be an issue. We'll deal with that in a minute. And the cube root of 8a cubed. The bottom should be okay because remember 2 cubed is 8, so the cube root of 8 is 2. But 162, let's take a look at that. 162. Well, it's 2 times 81. And 81 we know is 9 times 9. Well, the 9s break up into 3s. So really, it's 3 to the 4th times 2. All right, so let's rewrite this. We'll put the 2 first, just because you put them in order. 3 to the 4th, that's the top. And the bottom is the cube root of 8a cubed. All right. No big deal. We've got this. The 2 can't come out. It's stuck. It stays underneath. So that 2 is going to stay. Now 3, we got 4 of them, 3 to the 4th. So how many times does 3 go into 4? 1 time. So 1 3 comes out with a remainder of 1. So 1 3 stays. All right, so remember, you have a group of 3 with 1 extra. The 1 comes out, the 1 stays. Cube root of 8 is 2. Cube root of a cubed is a, because 3 divided by 3 is 1. So just to simplify that one further step, 2 times 3 is 6 over 2a. All right, no radicals in the denominator, nothing else to simplify, so that is our answer. 2 cube root of 6 over 2a. 3 cube root of 6 over 2a. You know me. English. That's not English, it's just me not being able to read numbers. My downfall. All right. We're going to do these next problems and we'll end the video and we'll start a new one after this. Okay? We are multiplying radicals. So here's that idea we talked about. If things are not under the radical, they don't go under the radical. And if things are under the radical, they stay. You just multiply them together. 3 times -4 is -12. And you can multiply 15 times 45 if you like, but we know it's going to be 15 times 45. Now we're going to break it down anyway, so why multiply them together? Let's break them down. The 15 is going to be 3 times 5. The 45 is going to be 5 times 9, where the 9 breaks down into 3 times 3. So notice, if we put 15 and 45 together, we're multiplying them, we're going to have 3 3s, and we're going to have 2 5s. That's the total breakdown. So what we end up with is -12 times the square root of 1, 2, 3. 3 cubed times 5 squared. Now, if you think of other ways to do it, that's fine too. If you thought of it, oh, like it's 25 and 9, and those are square numbers, that's great. That works. This is just an alternative. All right, what's the square root of 3 cubed? Well, remember, that's a square root. So 2 goes into 3 once, but that leaves us a 3 underneath. 1 has to stay. 5 squared. Well, 2 divided by 2 is 1. Nothing remainder. The 5 gets out. So just put these together. 12 times 3 times 5. Figures its multiplication. Hang on, I can do it. Let's see, that's 36, and 5 is -180 square roots of 3, and that is how you simplify it. Okay? All right, let's do one more, then we'll stop this video. Okay. 2 and 7, not under the radical, we multiply them together. 24 and 18, we're going to multiply them together. But instead of multiplying them just to break them apart, let's just break them apart now. 24. What do you want to do? 4 times 6, which means it's a 2 and a 2 and a 2 and a 3. Good job. 24. All right, 18. 2 and 9. 9 breaks down to 3 and 3. So let's see, what do we got? For our 3s, we have 1, 2, 3 of them. For our 2s, 1, 2, 3, 4. So what do we end up having? 2 to the 4th power, because we have 4 of them. 3 to the 3rd power. What comes out? Well, it's a square root again. So 4 divided by 2 is 2. Nothing remaining. 3 cubed. Well, 3 divided by 2 is 1, with a remainder of 1. So 2 goes into 3 one time. So 1, 3 comes out. 1, 3 remains. Now we've got to multiply 14 times 4 times 3, which is 168 square roots of 3. There you go. All right. It's the end of our first video. And hopefully it wasn't too bad. It was just the stuff we did last time, and we just added a little bit of extra stuff to it. So in our next video, we're going to continue adding extra stuff to it. So I'll see you later.